All right, hello everyone, this is Mr. Crozier. I'm going to walk you through 3.1 and 3.2, the practice quiz number 2. On problem number 1, you have to find some points and some slopes, and again, these are just estimations. Part B, draw a secant line, and here's my secant line. I went from this point to this point, and I have this secant line drawn through here. I'm going to go ahead and go over the secant line in red. There is a secant line going through there. And if I count the slope there, down 5 over 6. And you're welcome to pick any points for your secant line. And then on part C, you're finding the values where the tangents equal. So if I draw this right here, I draw this tangent line right there. Well, there is this point on the tangent right there, and that hits at about 0.5 or about 0.4, where the secant and the tangent are parallel. And again, that's what we're looking for on mean value. So just estimating it. Later on, we're going to figure out exactly what that 0.4 is supposed to be. Now when you get to problem number 2, well, now you have the case where you have a function and you can take the derivative and you can do the actual values with the derivative. And on part B, you can find the actual slope between the points, which we estimated over here to be negative 5, 6, which turns out to be exactly negative 5, 6 here. And on part C, you can use the mean value theorem, where you set the derivatives equal to, you set the derivative equal to the slope, do the work. At this point, I took the square root of both sides, and I had a positive and negative root of 6 minus 2. And the only one that works is going to be the positive root. And watch what this turns out to be. That turns out to be 0.44. Which is very close to what I said it was going to be over here. So these should match all the time. On problem 3, again, I have this graph, have a nice, neat graph. I can estimate all the points, and then down here on number 4, I can do the same thing with them. I can find the exact points, and you'll see this graph looking alike. Look what this does. This goes down, up, down, up. And if you do the first derivative test, down, up, same thing. So these two are tied together. All right, number 5. We're looking for a mean value theorem problem. We want the slope to be equal to the derivative. Well, the slope here is 0. Set that equal to the derivative, and I have answers of 1 and 3. Only 1 counts because we're looking for values that are inside the interval. On problem 6, this is a straight example of a first derivative test. I found the derivative, I set it equal to 0, and I know something happens at 1. I do the test, it goes up, then down. Number 7, hot air balloon over 0 to 3. Same thing again, it goes up, then down. At 1, it's the highest. That's what that test showed me. So I plug in 1, and I get 11 1/3 out. So I want the coordinates. At what it looks like on the chart is at input 1, output 11 1/3. Inputs to outputs. That's the highest output. Again, second derivative or first derivative test. Up, down, down, back to up. And you get these arrows by plugging in the derivatives. On number 9, same deal. Find the slope is negative 1. Set the slope equal to the derivative. And you'll see it's 2 root 2 years. And number 10, same thing here. Find the slope, 1/9. Set it equal to the derivative. Solve that. When you get down to here, a lot of times you don't have to FOIL this out. If you can just take the square root, you'll have plus or minus root 18 over there, and then always simplify that down. Problem 11 is a great problem. They start us off with this one function, and then your job on the one function is to find the average rate of change. Well, that's slope. It's done. Then you got to find the greatest and the least. Well, greatest and least is done by finding critical points. Find the max and the min. That's done. Problem D is just interpreting what it means. Find and interpret A of the slope at that point. Well, that's just a matter of plugging in the derivative. I have the derivative up here, right here, so I just take my 2 and I plug it into that equation right there. On the last one, when is the bacteria decreasing? Well, that's going to take this test. It's going to go up, then it's going to go down, and it's going to change at 1. And number 12, find the mean value theorem. Well, that's simply set the slope equal to the derivative. And it was a quadratic formula one. And the last one, the absolute extrema, again, checking from -1 to 5, and you're only checking critical points. So I'm only checking these ones here. And I have a minimum here and a maximum there. All right, hope this helps with your test.